In order to understand the day-to-day weather, we need to understand the composition of our atmosphere. So I'm going to talk a little bit about that. And we also need to understand this important player in day-to-day weather called atmospheric pressure, or pressure of gases in the atmosphere. So there's more than just gases in the atmosphere. There's actually suspended liquids and solid particles we actually call aerosols. But the reason that the Earth has these gases and particulates associated with it is due to the force of gravity. Now, if the Earth was a little less massive like Mercury, it wouldn't have an atmosphere. So it's about the kind of this critical mass that the Earth has to have the atmosphere it does have. But now the Earth's atmosphere is pretty darn thin. This picture down here is actually looking at I believe it's the ISS, International Space Station, and looking out across, I don't know if you can see, but this kind of little hazy, that actually is the Earth's atmosphere. So it's really pretty darn thin. It's about 60 miles thick. Now the atmosphere, it varies. It's thickest at the equator and kind of gets thinner near the poles. And compare that to a diameter of about 8,000 miles. So 60 into 8,000. It's pretty thin compared to the size of the Earth. One of the things that oftentimes we think of is the air that we're breathing. We think of that it's mostly oxygen, but it's not. It's actually mostly nitrogen. So oxygen actually hasn't always been a part of the Earth's atmosphere. It was kind of built up here after plant life established itself on the Earth. So that's kind of neat. We are living currently in an 80-20 nitrogen-oxygen gas mix in the Earth's atmosphere, but that hasn't always been the case. So I just note down here that, of course, we have gases that we're breathing and all that, but we also have suspended liquids and particles that are generally called aerosols. So we kind of think of the Earth's gases, the gases in our atmosphere, as either being permanent, okay, or being variable. Now, permanent means that they generally have the same composition at generally all locations, generally throughout the year. So I mentioned the 80-20, so you kind of see that. We have about 80% nitrogen, 20% oxygen, and followed by actually, almost just 1% argon, and then you can kind of see it goes down from there. Now, these are our permanent gases in the atmosphere. You might recognize some of these important variable gases, starting with water. So I think I mentioned in an earlier lecture that, of course, water can be either a liquid, a solid, or a gas. And if it's a gas, we call that water vapor. And this is by volume, but by weight, I think this is right, by weight, water can vary from 0 to 4% in the atmosphere. Sometimes there are places in the United States, for instance, that are dry. There are places in the United States that are with high humidity. Okay, so it definitely can vary from time to time and from location to location. The next variable gas is carbon dioxide. The notorious carbon dioxide. Actually, carbon dioxide used to be it's building up again, but it used to be, I mentioned when oxygen wasn't abundant, carbon dioxide was, and it got consumed by plant life, and now here we are creating more carbon dioxide in the atmosphere. Now, carbon dioxide will vary seasonally somewhat, and that's because of plant activity. So I think that's kind of neat. The third variable gas I have up here is ozone, and that actually has also been in the news and of some environmental concern. There is good ozone and bad ozone. Okay, the bad ozone actually is in the lowest part of the atmosphere called the troposphere, and the good ozone, which we're worried about ozone depletion, is in the next layer after the troposphere called the stratosphere. And the good ozone creates these ozone holes, okay, so ozone holes, and I'm not really going to go much into that, but those ozone holes are at the polar regions, okay, so like 90 degrees latitude, and they are seasonal. So the good ozone, we want to be there, but there are holes created because of CFCs in the past being used. I think that ends this part.